Hi, my name is Dave Semerink. I'm a Principal SE at Cohesity. Today I'll take you through Cohesity's 5 steps to cyber resilience demo. This methodology aligns with industry standards such as NIST, SANS, and MITRE Defend, and is designed to help organizations recover more quickly in the event of a cyber attack. The 5 steps are protecting all data, ensuring recoverability, detecting and investigating threats, practicing application resilience, and optimizing data risk posture. Step 1 covers protecting all data, including backups of on-prem data, replicating this data and archiving it. Ensuring Active Directory and ID are also protected. And this extends to cloud data in form of SaaS, PaaS, IaaS. All these datasets are managed through a single control plane. Cohesity provides a single dashboard for managing multi-cluster estate, the security posture of all clusters, and threats discovered in backup data. From the Data Protect application, we can also perform cluster management. We can also very easily update clusters centrally to the latest Cohesity versions. Cohesity supports a broad set of workloads. Here we can see various hybrid and SaaS workloads in our environment, supporting traditional on-prem hypervisors such as VMware, Hyper-V, and Nutanix, as well as cloud-based environments on AWS, Azure, and GCP. There is support for databases, traditional databases such as SQL and Oracle, but also modern databases. Broad coverage for various NAS sources, including NetApp and Isilon, as well as being able to protect any NAS environment that is able to expose SMB or NFS. Cohesity supports various Microsoft M365 applications, Mail, OneDrive, Teams, SharePoint, but also Entra ID. Furthermore, there's coverage for physical servers, covering Windows, Linux, and Unix, as well as various Microsoft applications. Active Directory is a particularly difficult application to recover. Microsoft's own guideline spans over 29 steps, documented over 150 pages, to enable you to do forest level recovery. Cohesity significantly simplifies this process. In this demo, we'll show you how to do a multi-domain controller forest level recovery using data stored on Cohesity in a secure and immutable state. To initiate a recovery, we simply log into our recovery console, select our forest that we want to recover, and initiate forest recovery, and provide a newly provisioned, unconfigured Active Directory server for our recovery. Now all I need to do is hit continue and start the recovery. As you can see, this vastly simplifies the process of being able to recover a forest, a process that would normally take days or multiple days to recover is now done in just a few clicks. So in summary, what we've just seen in step 1 is that Cohesity has support for thousands of data sources across hybrid cloud workloads. Cohesity is also very efficient, typically using 25 to 30% less storage footprint to store the backup data. Cohesity's instant mass restore function enables rapid recovery in the event of a cyber attack. Now we will look at step 2. Ensuring data is always recoverable. Ensuring recoverability involves 3 key actions: hardening backup infrastructure by locking down identity and access management, implementing lock retention of backups using Cohesity Data Lock, and implementing an air-gapped vault as a last resort copy should your primary environment be compromised. So let's look at hardening our environment. It automatically scans all Cohesity clusters and validates it against rules that look at ensuring the optimal hardening for your clusters. Things that we look out for is whether or not you have implemented multi-factor authentication on the cluster, whether or not your audit log settings are sufficient to ensure good visibility and recoverability, and whether or not elevated access rights into the cluster are still active or not. Non-compliant clusters can easily be found, and Cohesity also provides clear instructions on how to remediate insecure situations. Cohesity VoltNox provides a vaulting service supporting environments including AWS, Azure, GCP, and even on-prem vaulting clusters. Configuring a vault is also very easy. Here we can select one of our source clusters and assign different vaulting regions for it to be used. We can implement throttling should you be network constrained at certain times, and we can even implement different vaulting configurations in each region, supporting different storage classes, either warm or cold, to align with your recovery requirements. For each configured vault, we can also define variable vaulting windows so that you can control when the vault is able to communicate with your source environment and then disconnecting it. So here you've seen how easy it is to configure immutable backups combined with a vaulting copy. This ensures recoverability even if the primary environment is compromised. In step 3, we will look at detecting and investigating threats using your backup infrastructure. Cohesity supports ransomware anomaly detection, looking at encryption activity, being able to run malware scanning through file hashes, and looking at indicators of compromise and potentially detonating these in a secured sandbox environment. Cohesity is also able to send these alerts into your security operations center. One of the first things we have to define is how Cohesity behaves when it detects an anomaly. Does it need to send out an alert or notification to your SOC? Does it need to run additional threat scans using custom YARA rules or using threat feeds from Google Threat Intelligence or potentially CrowdStrike? We can also automatically trigger data classification scans on backups should it discover anomalies. Continuously monitors metadata characteristics of backups, comparing metrics such as data read size, data written, and entropy to detect anomalous behavior. And when an anomaly is identified, the platform provides a timestamp, location of the anomaly, blast radius identification, the ability to run snapshot comparison, the last clean versus anomalous snapshots, and to show you exactly what changed. Here I can see a snapshot with an anomalous event, with trending information, and a clear overview of the files that have been impacted as part of this anomalous event. Once an anomalous event is detected, Cohesity will start a threat hunt. Here we can see that threats have been found inside this snapshot. I can get some very clear information on this particular threat. Its sensitivity, groups typically using it, and how to potentially recover. Cohesity also provides the cyber recovery assistant to help you analyze events and help drive a recovery strategy. So here we have a quick analysis of all potential events of the last 30 days. In addition to anomaly detection, IOC scanning, Cohesity also supports rapid threat hunting by using file hashes. Because Cohesity automatically hashes each file it backs up and stores these hashes in metadata, we can run very fast scans across all protected workloads using a very simple hash method. These operations are typically completed in just a few seconds or a few minutes. So as you've seen, Cohesity enables you to use your backup as a forensic tool and help you drive clean recovery very easily. Now, clean recovery is obviously only possible when you also practice. That's part of our next step, practicing application resilience. Here we focus on regularly testing recovery plans before a cyber attack occurs. And this involves building a digital jump bag, containing the tools and environments used to respond to an attack, creating clean rooms and staging environments for investigation and remediation, and orchestrating the creation of these environments repeatedly using the recovery agent. First, we need to define a clean room. A clean room defines the resources for compute and networking running in an isolated environment for us to run our recovery scenarios automatically. We can also define which methodology we want to use for restoring data. In this case, we're using instant mounts. so that we can very easily spin up different variations of workloads without moving any actual data, which saves usually on time, and also scanning the recovered instances for indicators of compromise. Once we've set up our clean room, we can go and add recovery groups. A recovery group is basically a collection of sources. Here we can also configure different steps for an actual recovery or running a test recovery to ensure that the application is recoverable, as well as configuring threat scans to be run on the recovery group. Nextly, we'll look into blueprints. And with blueprints, we control the behavior of doing a DR to the clean room, a practice recovery, or an actual recovery. Here you can see us spinning up a recovery group into our clean room, pausing the environment, which gives us time to run scripts. These scripts will validate the health status of the recovery group, record the output, and finally tear down the environment once the recovery has been tested and validated. By practicing application resilience through clean rooms and orchestrated blueprints, the recovery process becomes repeatable and more reliable for when an actual attack occurs, increasing your confidence in being able to recover and reducing the downtime significantly. Effective detection and recovery decisions require a clear understanding of what data exists in the environment. This is exactly what we'll look into with step 5, where we integrate data security posture management classifiers and perform data classification on backup data of Cohesity. We'll now navigate into Cohesity Security Center and look at the security inventory. This view shows all the objects Cohesity Helios has detected in the environment and the actions Cohesity is taking on them. Here we can see a cloud bucket where Cohesity is performing data protection, detecting anomaly, scanning for threats, and potentially also folding this backup data into Cohesity Fort Knox. What we can see here is that this object also contains sensitive data. So we're detecting restricted data, business IP, as well as financial, health, IT, and personal data. Here we can see more information on the object, the actual account ID, the data storage type, where it's located, how much data is there, when it was created, and whether or not it is still active. We also get a breakdown of all the data categories that we've identified to be present in this particular bucket. For example, we're seeing that data is not encrypted or that access to the object might be exposed. And we can click into these to get a clear understanding of what's going on. Here we actually have identified that there's an external account that is trying to access this resource, and it's currently not being monitored. In addition to this live exercise of identifying data, the Cohesity data platform is also able to retroactively classify data that is sitting in backups. And again, this will also help you make informed decisions about what to recover in the event of a cyber event. So here, in this particular demo, we've gone through the 5 steps of cyber resilience. Protecting all data on-prem, cloud, and protecting identity all through a single control plane. Ensuring that we can recover by hardening our infrastructure, data locking backups, and air gapping a vaulted copy of backup data. Being able to use the platform to detect and investigate threats, where we can provide anomaly detection, threat scanning, and SOC integration. We can practice application resilience to clean rooms, staging environments, and orchestrate blueprints through the Cohesity Recovery Agent. And finally, we can help you optimize your data risk posture by providing integrated DSPM and data classification on backup data. Cohesity is the only platform that delivers all 5 steps of cyber resilience alongside an empowered data lake in its platform. Thank you for your time, and I'm looking forward to meeting with you next time.